Welcome to the Global Mapper webinar for the month of May. At this time, you should see the introductory slide on your screen. Currently, all attendees are in listen-only mode, which means you can hear the presenter, but your microphone is automatically muted. If you have any questions during the presentation, you can use the Questions tool on the GoToWebinar panel to the right of your screen. Our panelists will try to answer your questions as they are submitted, and, if necessary, the presenter will address any outstanding questions at the end of the presentation. We will respond to as many as we can during the session, and will follow up via email on any remaining questions. Remember, for ongoing questions about the features and functions of Global Mapper, you can always email our support team at geohelp@bluemarblegeo.com. Before we begin, we would like to announce some upcoming dates where you can come out and meet some of the Blue Marble staff and learn more about our products. On June 6th, we are hosting a Global Mapper Lunch and Learn event for local government in St. John, New Brunswick. If you are interested in attending, please visit our website for more information or to register. On June 12th, we will be exhibiting at the Geodata Conference in Dublin, Ireland, and during the week of the 25th, we will be at the OpTech Imaging and LiDAR Solutions Conference in Toronto. If you're planning to attend any of these events, please stop by our booth and say hi. We'll be happy to show you the latest versions of our products or answer any other questions you may have. We will be hosting a free Blue Marble User Group Luncheon on July 10th at the Esri User Conference in San Diego, California, and we would also like to invite you to sign up for our 2-day Global Mapper training being offered on July 11th and 12th in San Diego. For more information or to register, please visit the Blue Marble website and click on the training link in the support menu. During today's presentation, which will be about 60 minutes in duration, we will explore the 3D functionality of Global Mapper. Among these topics, we will be creating and manipulating terrain surfaces, LiDAR data processing, assigning elevation, height, or depth to vector objects, and performing various analysis functions using 3D data. A recording of today's webinar will be available online and, along with previous webinars, can be accessed from the Blue Marble webpage. At this time, I would like to introduce David McKittrick, Senior Application Specialist at Blue Marble.
Thank you, Raina. And once again, thank you all for taking time out of your busy day to attend the latest of our Global Mapper webinars. You will notice the screen in front indicates that we are now up to Global Mapper 14.2, a new release as of the last couple of weeks. We will actually, jumping ahead till next month, we will be talking a little bit more about what's new in this version in our next webinar. But just to kind of give you a foretaste, we're going to be using Global Mapper 14.2 today. If you're currently using any version of Global Mapper 14, this is a free upgrade. You can download it today or after the webinar and update to the latest and greatest. If you're on an older version, again, then we do encourage you to keep current with the latest technology that we're integrating into the software. You can download a trial, use it for 2 weeks, and see if it works for you. So, as Raina mentioned today, we are going to be looking at 3D data in Global Mapper. A little bit of a different approach for us this month because we're actually going to be using both Global Mapper and the Global Energy Mapper. Certain functions are applicable within the standard version. Certain functions I'm going to show you are exclusive to Global Energy Mapper. This might provide enough of an incentive for you to take a look at Global Energy Mapper as an alternative to the standard version. So again, I will try to make sure when I go through the presentation to note that we're actually using Global Energy Mapper for particular functions. The agenda, or the abstract I should say, for today's session, as was published on the website and as you received in your announcement email, indicates that we are going to be looking at Global Mapper's 3D modeling and analysis functionality. It is a major part of the software in terms of recent development and our development plans for future versions. We're looking at expanding the functionality of the 3D component in Global Mapper. Any of you who have used Global Mapper will, I'm assuming, be familiar with working with elevation data. We will be going over some of those basic functions, but we're also going to look at using some vector or applying a z-value or an elevation or a height value to vector features as well, and essentially modeling those features in a 3D environment. So we're going to explore various aspects of working with 3D data within the context of Global Mapper. Specifically, our agenda today, we're going to first look at some sources of 3D data. There are excellent online sources, especially for those of us here in the US, and we have some worldwide sources as well that we can point you to. We're also going to look at accessing data from very simple files, even little text files, where we can actually generate terrain surfaces from a text file. We're also going to look at LiDAR data, increasingly important in the world of terrain analysis is LiDAR data. We're going to look at how Global Mapper can work with LiDAR data and how we can generate terrain surfaces from LiDAR data. And as a good segue, my second bullet is generating our terrain surface from those data sources. So we're going to generate elevation surfaces, modeling the terrain in a 3D environment. Some of the configuration options within Global Mapper, for those of you who have maybe dabbled in this part of the software, we'll give you some pointers as to how you can configure that 3D, some customization options you can apply, certain settings, filters you can apply to that 3D data, and we'll go into some of those configuration options. I have an entire bullet here called terrain analysis, and this is going to be the majority of the presentation today, where we'll talk about various functions, various tools, various processes that can be applied using or utilizing the 3D data that we've imported. Things like watershed modeling. We'll do some variations on the theme of watershed modeling. We'll do some other 3D analysis functions as well. Manipulating elevation, essentially modifying the elevation, is another broad theme we're going to be covering. Offsetting elevation perhaps, or modifying the terrain based on perhaps local requirements, maybe building requirements. We'll talk about some of the modifications we can make in terms of creating an artificial terrain surface. So we'll talk about manipulating elevation. And this is where we kind of change tack just a little bit, because we're not only dealing with surface z-value, surface elevation, but we'll also talk about how you can integrate a z-value, a height, or a depth, if that's applicable, to vector data, linear features, area features. You can assign a third dimension and essentially model those in a 3D environment as well. And finally, and towards the end of our presentation, we'll address the idea of exporting 3D data, getting 3D data out of the application, perhaps in a file format that's used in another application. So that's the basic plan for today, the plan of attack. As I said, I'm going to be using a couple of different versions of Global Mapper. We're going to be restarting with the standard version, and as I indicated in my presentation, we are up to version 14.2. And as needed, we will also be looking at Global Energy Mapper. First thing we're going to look at is our sources of data. How do we begin the process? For those of you who are new to working with elevation data and you want a good jumping off point, how do you begin? Well, an excellent source of elevation data is available right from within the application, where you can click on the Download Online Data button, my cursor in the upper left corner of my screen. We can also click the button right in the middle of the screen, Download Free Maps Imagery from Online Sources. In either case, it will bring up our Download Online Data access window, where we can choose which data that we want to access. These are WMS feeds. These are pre-configured web mapping services that provide direct links to some readily available data sets. You can, as we've mentioned in the past, add your own data sources as well. So perhaps if your local GIS office provides data online, you can add that source manually. You can essentially type in the URL or paste the URL and access the data from that remote server. But again, for those of you who are starting off in this process, the terrain data category within this window provides some links to pre-formatted, readily available data, some of which is what we define as premium content. In other words, you would need a subscription from that data provider to access it within Global Mapper, but there are a number of free data sources as well. And again, specifically to those of you who are within the bounds of the US, we have the US National Elevation Data Set accessible free of charge. You can download that data, save a local copy to your hard drive, and have access to that 10-meter resolution elevation data. We're going to be working with some of that data a little bit later in the presentation. And again, in the interest of bandwidth, I'm not actually going to proceed with the process, but you simply click the appropriate link and you click Connect, and it will provide you with that data initially without any other reference data. And if you choose the entire data source bounds, you'll get a map showing the entire continental US, and you can zoom into a particular area of interest if necessary, or you can define your area of interest right within this dialog box. So again, we will be coming back to revisit this data, a locally saved version that I've imported or downloaded previously. For the time being, I'm just going to close this dialog box. So another source of data, another source of elevation data, is simply an X, Y, and Z file. I'm going to show you an example of a simple text file that contains simply a X value, a Y value, and in this case it also has a Z value. These are eastings and northings in this context, but this could also be a latitude and a longitude, again with an elevation value assigned to it. We're going to go ahead and import this and generate elevation data from this very simple file. Before we do, it's also worth noting that knowing that this type of data format can be used to generate a terrain surface, it's certainly possible for you with a common off-the-shelf GPS receiver to collect this type of data, essentially collecting a waypoint with an elevation value. Obviously, the precision of elevation is going to depend on whether your GPS device has an altimeter, but if it does, you can very easily generate a file like this and generate a terrain surface using the process I'm about to show you. So the source data is obviously very, very straightforward. To get the data, to import that data into Global Mapper, we're going to the File menu, and we're going to open a generic ASCII text file. Now, we can use this for many processes, simply importing points, importing a boundary file, perhaps. In this case, we're going to import our text file that includes our X, Y, and Z values. And as you'll see on the screen, it's going to prompt us to decide or to set the structural parameters of this file. We can bypass the point rendering and simply generate an elevation grid directly from this point data. So a very simple source of elevation data and a very simple way to create a terrain surface is simply to import the text file and immediately grid that file. In my case, I'm actually going to render the points first, so we can essentially do it as a two-step process as opposed to a single-step process. My coordinate parameters, our easting is first. There are no fields to skip at the start. We previewed the file. There's no rows to skip. I don't have any header information. We're going to use the auto detect to determine the delimiting characteristic. And we are going to make sure that our third coordinate value is considered our elevation value. Now, I've had some questions in the past from customers who use this function, but the elevation value is not actually the third coordinate value. It may be the fourth, fifth, or sixth field in a text file. If that's the case, there is a way to manually assign the elevation column. In other words, if you have a column of information in an imported file, you can decide which of the columns of data contains that Z value. And I'll show you that in just a second. But for the time being, the third value in my case is the elevation data. I simply click OK. I determine the projection parameters for my coordinates. Global Mapper just sees values. It does not know what those values are. So in my case, this is a state plane coordinate system, main west. You can obviously set the individual projection parameters for the file we're importing. And I'll simply click OK in this case. And as you'll see, I end up with an array of points. This is a simple point import tool. If I use my feature info function within Global Mapper, you'll notice I have an elevation assigned to each of these points. So I have essentially the raw material for generating an elevation surface. Now, as I've mentioned previously, if you have a similar text file but the elevation value is not the third column, you can select the layer that you've imported, select the options button, and choose to get your elevation from a specified attribute value. So that might be the fifth or sixth or eighth column of data that you've imported. In my case, I've already pre-selected that. It's using the default, so we're OK. So to create an elevation surface, there are actually two ways you can do this. One is from our relatively new analysis menu, where we can create an elevation grid from any loaded 3D vector data. This option would allow you to essentially generate a surface from multiple loaded files. If I had multiple text files and I wanted to create a single elevation surface, I can use this function. Or if I want to generate an elevation surface for a specific file, which in this case I've obviously only got one, I can right-click and I can choose grid. And ultimately, in my case, it will be the same end result. The window you're seeing on your screen now is our standard grid creation dialog box, where we can specify the parameters for the grid that's going to be created. I'm just going to leave this with the default values. and I'm simply going to click OK. And when I do, you'll see that the points, which are still visible, I'm just turning them off temporarily, have now been gridded using a TIN process, a triangulation process, to create a terrain surface. So essentially what was a series of simple point values can be rendered as a terrain surface. The coloration of the terrain surface is reflected in the elevation legend that you'll see on the left side of my screen. And we can define these colors based on a number of settings, a number of pre-configured settings that will reflect things like actual elevation, or if it's more appropriate, we can reflect slope or slope direction. I'm going to come back and address those issues just a little bit later. But as a very simple way for creating an elevation surface, starting with some point data, this is a very, very easy to use tool within Global Mapper. The next example of a source file that I'm going to use is LiDAR data. And for this, I'm going to unload the file I just loaded. I'm going to load a pre-configured workspace that covers an area just to the east of where we are here, pretty close to the coast of Maine. This is the town of Castine, a very historic town, very prominent during the American Revolutionary War. I have some LiDAR data that covers at least most of the town, and I'm going to go ahead and import that LiDAR data. The import process is a simple file import, and I'm going to choose a .laz file. This .laz file is a compressed LiDAR file. Global Mapper will also work with the uncompressed, the .las. But in this case, obviously, the compression saves a little bit of space on my hard drive, so I'm just going to simply import that layer. Now, for those of you who have never worked with LiDAR, essentially what LiDAR is a point data set. What we'll see in just a second are a series of points that were captured by a remote laser-based data collection system that is able to determine not only the precise X and Y for every point, but also the Z, this precise elevation. There is additional information assigned to each point, which we will just see in just a second. But for the time being, I'm just simply going to import this layer, and we can render the points. Now, during the import of our LiDAR data, you'll see this this options window that appears that allows us to apply certain settings to the imported data set. There are certain filters that can be applied. You can also bypass the rendering of the points, as we could have with our text file, and simply generate an elevation surface. In my case, I'm going to import the entire file without any filtering. I'm simply going to click OK. And this is a file, I think it's about, I think about 10 million points. So it takes a few seconds to import. And when it does, what you'll see on the screen is an array of points. Now, at this level, it does not look like points. It looks like a solid surface model. And the reason for that is because, by default, Global Mapper will automatically assign the elevation value based on the shader pattern that we had previously noted when we imported our text file. So we've already got a simulated model of the terrain by just simply looking at these point values. I'm going to zoom in just a little closer here, just to a defined area. And what you'll see when you zoom in is you'll start to see the individual points that are now distinguishable. If you glance down at my legend here, I'm using my scale bar. I'm using a feet scale bar. You'll notice that these points are fairly close together. This is 5 feet is from about my location of my cursor now right to this point over here. So that's a 5-foot distance. So these points are very close together. And as a result, when we generate our terrain surface, as we will in just a second, it's going to be a very precise terrain surface. It's going to be a highly accurate terrain surface. Now, before we go any further, there's a few things that we can do with this point data set. The visual characteristics, as you see, are based on elevation. But it is also possible to change how these are portrayed to reflect some of the other characteristics of the data. Before I do that, I'm going to use my Feature Info tool again and select a point. Each point, as I mentioned before, has an elevation, but it also has a class. The particular point that I selected of the several million is a ground point. This is a ground point that I can use for generating a terrain surface. There are other points in this layer that I think in this particular case are defined as unclassified, but they may represent things like vegetation. they may represent roads, they may represent other distinguishable characteristics. And those parameters can be established during the data collection process, where whoever collects that data remotely can decide on how the data is classified or what is presented. So I can change the visual characteristics of this file to reflect some of those other variables. In order to do this, I'm going to click on the last file, the LiDAR file, which I had mentioned is about 9 million points, just over 9 million points. I'm going to click my Options button in the Overlay Control Center, and I'm going to choose to distinguish the points not based on elevations, which is the default because we don't actually have any colors assigned to each point. I'm going to choose Intensity, and I'll just click Apply and keep the window open. And you'll see when the screen refreshes, the visual representation of the points now reflects the intensity value of the return. The brown points in this case are my brown points. The gray points are unclassified, and these pink points are actually overlap, where the two of the flight lines would have overlapped. So those are just some of the visual characteristics that can be applied. I'm going to go back to the default so we can render our points, again, based on actual elevation. One of the other new features that we've added fairly recently when working with LiDAR data is the ability, let me cancel the window and go ahead and open up my, I'm sorry, let me cancel out one more time. Let me open up my metadata window. The metadata window is not a new function for Global Mapper. We've always had that option for any loaded layer where you can look at the particular parameters of that layer, the bounding rectangle, the point or area count, etc. But with LiDAR data, we have a new tab called Statistics, where we can render the statistical breakdown for a given LiDAR layer. And here we can see at the bottom of the screen, of the 9 million points, we have just short of 2 million that are defined as unclassified. The ones that we would be most interested in are ground points. There are just under 2.5 million of those points. So you can see the breakdown. You can see the elevation range within each point. You can see where there's some erroneous data points, for instance, or overlap, etc. So you can conduct a certain amount of analysis of this data and perform whatever filtering you need to screen whatever data you don't need to have rendered. What I'm going to do with this data, or I'm going to simulate, just in the interest of time, is create an elevation surface. Now, I didn't filter the data during import, so I'm just going to simply uncheck this, and I'm going to turn on the elevation layer that would have been created had I gridded it. Now, the gridding process is exactly the same as I performed with my text file. It's a right-click on the file and choose Grid, same dialog box as before. In this case, I've generated an elevation surface, which I'd previously done, just again in the interest of time, and you'll see the results of that on the screen. This is a very high precision, high resolution elevation surface. Now, what you're seeing on the middle of my screen right now is a very interesting feature within the town of Castine, which is a revolutionary fort, and you can obviously see the ramparts of that fort very clearly represented in the elevation model. You will also notice, if I zoom in just a little closer, you will also notice an interesting structure, almost a arc or circular structure that's rendered right here in the corner of the inner part of that fort. And if I turn that imagery on once again, what you'll see is it's actually a baseball diamond. I'm not sure they played baseball back in those days, but obviously they're very opportunistic in Castine. They're using that flattened surface to play some baseball. But what's interesting with this LiDAR data is the minute variation in elevation change between the grass area and the dirt area is distinguishable based on the rendering of those points. So again, LiDAR data is another source of elevation data. Again, very high quality in this case. You can get very precise contours, very precise analysis of your elevation data. Very quickly, I'm going to show some of the configuration options, and I want to make sure we do leave enough time to go through the various analysis tools. There is an option when working with 3D data to enable or disable what's called hill shading. And the hill shading pattern, as you'll see, is this shadow effect. if I turn off my hill shading pattern, which is a button in the toolbar, the data itself has not changed, but the shadow effect has been modified, or has been removed in this case, I should say. So the hill shader accentuates the terrain, allows you to visualize the terrain in a much clearer way. I want to show you in just a few minutes a way that we can actually use that hill shader pattern and integrate it within another layer. So there's a very interesting illustration I'm going to show you using that hill shader pattern. We can also render our map in 3D, and this is where the real visually appealing work in the 3D environment resides. Next to my hill shader button in the toolbar, we have a 3D button. And the 3D button actually opens a separate window and renders our data, renders our elevation data as a 3D model. This is a separate little window in and of itself. It's just got its own menu items. We can change the perspective, change the zoom level. We can simulate water level rise in here, just visually representing increases in water level. We can increase the vertical exaggeration to accentuate those terrain features. And there are various other settings that we can apply. We'll be coming back and looking at some of those a little bit later in the context of some of the analysis tools. So visually, we can zoom, pan, move around, and look at our 3D data in all its glory. And again, you can see in this case, my 3D data is very high quality. I'm getting a lot of precision in terms of the rendering of these 3D features. I'm going to change focus slightly here. I'm going to actually open up another version of Global Mapper. Just bear with me for just 1 second. I'm going to open up a fresh version. I'm going to load up a lower resolution elevation data set. This is, again, an area somewhere along the coast of Maine. This example is an elevation data set that I acquired using that 10-meter NED data that I referenced through the download online data dialog box. In this case, I saved a local subset of that data and actually cropped it to the boundaries of the town, in this case, the town of Gardner in Maine, and that's why you're seeing this shape. Now, what I'm going to do in this case is I'm actually going to let me actually load up a different data set. Just bear with me for just 1 second. I'm going to load a workspace. And this is the one I want. It's the same data, but in this case, I've actually loaded up a topographic map as well. What I'm going to do with this data is I'm actually going to visually represent the elevation data from the underlying terrain model as a component of my topographic map. Basically, you're looking at a USGS topographic map right here, and I want to change so that we can actually see the underlying elevation data. We can see certain components, specifically the hill shading, on top of the topographic map. Now, there would be various ways of approaching this. You could apply a transparency value, which works but in certain cases, but it tends to wash out the colors. What I want to do instead is I want to apply a blend, and I want to essentially multiply the colors from my underlying elevation data and apply them on the surface of this topographic map. In order to do that, I want to change the hill shader pattern to what's called a daylight shader. Now, a daylight shader, as you will see, it renders the entire elevation data set as a solid color. In this case, it's a blue color. I want to change that color to a white color for reasons you'll see in just a second. In order to do that, I have opened up the configuration dialog box using my configuration button, and I want to choose my shader options. Now, the shader options allow you to dictate the visual characteristics of any loaded elevation data. In my case, my daylight shader, as we can see from our legend, is a blue color. I want to change that to a white color. There are other options in terms of determining the visual characteristics of loaded elevation data. You can change the gradient shader. You can even create your own shader pattern with your own custom colors if necessary. But in my case, I just changed the surface color for my daylight shader to a white color. Now, I'm going to use my swipe tool once again, and you'll see as I pull back, all that I'm seeing now is my hill shade pattern. I'm not actually seeing any variation in elevation. I'm just seeing the hill shade pattern. Because now what I want to do is I want to pull that hill shade pattern and have it rendered on my topographic map. In order to do that, I'm going to open up the Overlay Control Center, and for my loaded topographic map, I'm going to choose my options. Again, for the topographic map, select the Options button, And the blend mode I'm going to apply in this case is a multiply. Essentially what I'm going to do is I'm going to multiply the colors that are in the underlying layer with the topographic map. And as a result of the process, what you'll see is a merging of those two layers. I have the underlying elevation data, specifically the hillshade data in this case, because my daylight shader is just white. And now I'm actually seeing those on the topographic map. This is a great tool for allowing you to take some of these loaded elevation data sets and apply them to a raster layer. In this case, applying them to a loaded topographic layer, a topographic map, I should say. So again, those are some of the data sources for elevation data. We talked about LiDAR, we've talked about simple text files, and we talked about some of the online data sources. One of the other methods for getting elevation data is to download data from a readily available source. Maybe your local GIS office may have elevation data. There are a number of supported formats that Global Mapper can work with. DEM is a very common one, digital elevation model data. So there are multiple ways of getting data into the application. We'll go back to casting again. We'll just go ahead and load up what we had previously. And again, I'll load a workspace that's pre-configured. And we'll take a look at the high-resolution elevation data set, and we'll talk a little bit about some of the analysis that can be applied to these loaded elevation layers. In this case, I'm going to turn off my elevation and turn on just the elevation model itself. And for this particular scenario, I'm just going to zoom into a defined area. I'm going to zoom in kind of close. One of the most simple tools you can apply within Global Mapper to any loaded elevation data set is the ability to generate contours. From the analysis menu, we have a generate contours menu. Generating contours is a very simple procedure where we define first off our contour interval. I'm just going to make these 1 meter contours. And we can define an elevation range for our contours. We can define the minor and major contours, which determines which ones will be bolded. We can also, within this dialog box, generate spot heights. This is an extremely useful tool for determining within a defined area what the maximum height is. And you can add that as an option when you generate contours. In the interest of time, I'm going to limit my contours to just the data that's currently on my screen. And I'm simply going to click OK. And what you'll see as a result is a new layer in my overlay control center. In order to see it a little clearer, I'll turn off my elevation grid. And you'll see those contours have been generated. These are vector features. These are in vector form. That can be exported to any of the supported vector formats and obviously transferred to any other application that you happen to be working with. Contour generation is a very common component in terms of the use of Global Mapper. A lot of people use it for generating contours. You can very simply build a script for those of you who have worked with scripting to generate contours based on your defined parameters. So contour generation, very, very simple process. I'll load up my gardener data one more time. I'm jumping back and forward just a little bit here, but I want to show you another example of generating contours or the contour generating function. In this case, again, I'm going to go to the analysis menu and I'm going to generate contours. But in this case, what I'm going to do is actually generate a specific contour. Instead of a contour interval, which in my previous example was an interval of 1 meter, I'm going to define a specific contour. In this case, I'm going to type 100 meters. In other words, what I'm going to delineate is just the 100-meter contour line. I'm also going to check the box further down here, which allows me to generate area features. Instead of just a line, it's actually going to generate a polygon or an area that represents everything that's over 100 meters. So the combination of those two functions lets me create features that delineate areas that are over a certain elevation threshold. And we'll just go ahead and click OK for the entire balance. And you'll see on the screen the vector features representing those areas that are over 100 meters. Now, to put this in some sort of workflow perspective, I'm going to turn on a layer with some parcels. And I'm going to select my 10 features, my 10 areas over 100 meters. I'm just going to select them with the digitizer tool. Because what I can do now very quickly and very easily is determine which of my parcels or which of my properties are over a certain elevation. So if you're interested in determining siting for a transmission tower or perhaps a wind farm based on a required elevation, you can very quickly use the selection tool to find those areas, those parcels in this case. And those are delineated in yellow. Those property owners have properties that have an area over 100 meters. So a very simple little tool for generating those area features and then applying them, in this case, to create a subset of my parcels there. So again, it's an example of analysis tool using our elevation data and as a byproduct of our contour generation. We'll load up another workspace. Try to keep these pre-configured to make it as smooth as possible. We're going to take a look at some watershed modeling. And again, in this case, I'm going to use a low-resolution data set. I'm going to use the same data set we have loaded now, actually. Let me actually load it up again. This time it will onload all of my pre-existing data. There we go. The watershed modeling capability in Global Mapper, again, is accessed from the analysis menu. It allows you to delineate watersheds within a defined area, in other words, stream catchment areas and stream models. I'm going to show you two very specific examples of this tool where I'm going to trace the flow from a defined location and trace the catchment area that flows to a defined location. So these are two slight variations on the theme of watershed modeling. In order to perform this analysis, what I'm doing is I'm selecting a point. I'm going to go to the analysis menu, and I'm going to go to watershed generation. Now, I'm not going to take the time to go through all the options in here. Simply what I want to do in this case is show the flow from this selected point. I'm going to do my water drop analysis, and I'll simply click OK. And what's going to happen as a result of this process is it's going to delineate the stream models, and it's also going to show me from that point where, all things being equal, a drop of water would flow. This is excellent for analyzing outflow if there are regulatory issues in terms of facilities placement or construction projects or things like that. Or perhaps if you're in the pipeline industry, if you have a break in a pipeline at a defined location, you can trace where the flow would be from that break location. So that's a very, very useful tool for that particular application and very simple in terms of its implementation. Let's go ahead and close our watershed model. I'm going to perform a slightly different analysis. I want to select a different point for this. We traced the flow from a point using the watershed modeling tool. I want to go into the watershed modeling dialog box once again, and in this case, I want to trace the flow to a point. So I'm going to deselect what I had selected previously. Drainage to a selected point. In other words, when I generate this feature, it's going to be an area that encompasses the full extent of flow to that location. Perhaps this point represents a public water supply location where they extract water for consumption. And you can see within this defined area, all of the streams flow to that point. So this allows you to delineate maybe an area that will be off limits for construction or for some other type of process. So watershed modeling, very, very useful component of Global Mapper. Again, utilizing the fact that we have our Z value, the fact that we have our elevation value. For the next analysis tool I'm going to show you, I'm actually going to switch to Global Energy Mapper. And I'm going to load up my Castine data one more time. Again, I have a preloaded elevation layer. I'm going to turn off my imagery. I'm going to turn on my elevation layer. I'm going to zoom into a particular location. You'll see visually represented an area that looks like it's a rise. Maybe it's an upland area, or perhaps it would represent like a pile of material. We have tools we've developed recently for Global Mapper that allow us to calculate the volume of material within a defined area, within, in this case, simulating this being a pile of material, what would be contained within that. Useful if you're working with a contractor who needs to remove perhaps material from a mine site, and you can very easily calculate those volumes. The way that we've implemented this in the most recent version of Global Mapper is simply by delineating or outlining the extent of a pile, as you can see. And I'm just going to right-click to finish that feature. So I've drawn a feature on my screen. I'm just simply going to select that feature, and I'm going to right-click. With my digitizer tool selected, we have an analysis measurement function, which allows us to calculate the volume within a pile. defined by an area feature that I've created. Now, the way this works, obviously, the specific elevation values that are underneath the linear or the area feature are going to be used to determine the actual volume of material. And this is a very simple procedure, a very fast procedure. In this case, my total volume is indicated at the bottom of my screen. About 5,700 cubic meters of material are within this area. So if I was trying to draw up a contract to have someone remove this material, I know very precisely how much material needs to be moved. So very useful tool and very easy to use, as you can see. Now I'm going to show you a slight variation on that tool. As you can see, very, very simple. This particular feature under my cursor, as you can see right here, it's not an elevated surface, but it's actually a depression. And what's interesting is that if I turn on my imagery, I have some overlying imagery, it's very hard to determine there's anything there until we remove the foliage cover. And you can see, I believe this is actually an abandoned quarry. Now I'm going to repeat the same procedure that I had performed before, where I delineate the outline of my depression in this case. And once again, I want to determine the volume of the depression, how much volume is within that lowland area. Again, same procedure. I right-click, I go to my analysis measurement, and although it says pile, in this case, what I'm most interested in is my fill volume. So this fill volume value right here represents the area of the depression, the volume of the depression, I should say. So it gives me the capacity of this lowland area. So those are just two variations on the theme of generating or calculating elevation within a defined area, or calculating the volume within a defined area. Now, while I have Global Mapper, Global Energy Mapper up and running, I'm going to show you one of the tools that really we've been working on a lot recently, and that's a tool that allows you to modify the terrain, essentially manipulate the terrain, flatten the terrain based on a defined area. Those of you who use Global Energy Mapper will be familiar with our pad placement tool. This is a nice addition to that function, whereby after you place a pad site, you can then determine the optimal elevation and model that on the terrain. Now, just to simulate that in my case, I'm just simply going to draw a rectangular feature here. And obviously this doesn't have any bearing on anything that's real, it's just as a simulated flattened area. For those of you who have Global Mapper, this is a function that is available in a form within Global Mapper, but it has really been optimized for Global Energy Mapper. So if you like what you see in this little demonstration, I strongly encourage you to take a look at upgrading to the Global Energy Mapper version. Essentially what I have here is a simulated surface, a simulated flattened area. Let's say we've outlined the area of a construction site. It's obviously not on a flat surface. If I bring up my 3D map, you will see that it's, let me go click my home button, and it'll take us to that area. My feature is hard to see right here. It's an outline, a black outline, but it's obviously not flat. There's some undulation in the terrain here. So my engineers require that this is a flattened surface. Within Global Energy Mapper, we have a very, very simple tool for simply creating that flattened surface. Right here within my advanced feature creation options, having previously selected that area, I now have an option to create a flattened site plan from this area. In this case, I want to optimize the flattened height. In other words, I want Global Mapper to tell me what the break-even would be, so I don't have to remove fill or add fill to this area in order to flatten this defined area. I also want to factor in some slopes. Let me just bring the slope value down just a little bit. A 0.3 slope is the same as about a 1 in 3 slope. And so I'm going to have some slopes outside of the area. In other words, integrating this flattened area into the existing terrain, instead of it being a vertical cutoff, it's going to be a slope cutoff. Again, this is a feature that's unique to Global Energy Mapper. I'm going to click OK. Now, as a result of this process, we're going to get a couple of pieces of information. First, we're going to get our cut volume and our fill volume, which should be almost the same. And as you can see, my fill volume is a little under 4,000 cubic meters, as is my cut volume. So that's what we expected, because we wanted the Global Mapper to optimize and balance those cut and fill values. The other thing that we'll get as a consequence of this, if I click OK, is a modified flattened surface model that shows us what that flattened terrain would look like integrated into the surrounding terrain. And because in this case I've integrated slopes, you can see those very clearly represented here. Oops, excuse me while I move around just a little bit. You can see those slope values now. And the calculation of volume will factor in the material that's required to create these slopes, both downslopes and the cut for the upslope areas. So a very efficient, very easy to use tool for generating very precise volume calculations and also for creating this modified terrain surface to visualize what that will look like. So that function, again, is a function that's unique to Global Energy Mapper. There is a variation that's included in our standard version, but certainly it's optimized for the Global Energy Mapper application. We're back in the standard version again, and I'm going to open up one other scenario. During my intro bullets, we talked about working with terrain data, which is what we've done up to this point. We've done some analysis based on terrain. We've generated our terrain surface from multiple sources. Now we're going to take a look at assigning a z-value to a vector feature. For this, again, I'm going to open up a pre-created workspace, and I'm going to show you how this process would work. Now, this is, again, I've simulated perhaps a building site. I'm going to generate a very simple rectangular feature here. I'm actually going to give it a distinct visual characteristics. I'm going to override the default. Actually, I'm going to customize the style based on my specific requirements. We'll make it a gray feature, so it's easy to distinguish. We'll make sure it's a solid fill color. So all I've done here is simply created a rectangular feature. Oops. I have to make sure my layering is appropriate. Oops. Not quite sure why that's not appearing on the bottom. Let me turn off the, there we go. There we go. There's my rectangular feature. The rectangular feature currently doesn't have any elevation value associated with it. The way that we can do that in Global Mapper is simply to select it, or you can do this obviously when you're creating the feature. Right-click, choose your Edit menu. You're going to edit some of the component characteristics of this feature, and add an attribute. Now, as we recognize when we imported those point data sets, we can assign a z-value not only to points, and as it was the case with our imported data, but in this case to our elevation or our area feature. I'm going to make this a height value. I'm going to make it about 10 meters, and we'll click OK. Now, you'll see I've simply added this as an attribute. Because it's called height, Global Mapper will automatically recognize this as a z-value. I don't have to make that assignment. However, if I needed to, I could go into the particular layer that contains the feature, and again, as I mentioned before, decide on which column contains the height value. I don't have to do it in this case. That happened automatically. Now, the feature has a z-value. It has an elevation value. I'm going to show you how we can model that in 3D. I'm just going to bring up my 3D window. And you'll see initially my z-value is not being used. So I'm going to change some of the settings in here. First of all, within the 3D view, I can display my vector features in the space above or below the terrain surface, which is what I want to do. I'm simply going to click Apply. Now, initially, because that z-value is a height value, it's assuming it's based on sea level, which is not the case in my example. So I want to check the second box, which allows me to treat the vector elevations relative to the terrain surface. And again, we'll apply that. I may have to click the Home button here. There we go. So my 10 meters is now above the terrain. So you can see now my elevation has been assigned to this feature. What would be great would be to actually fill in the sides to simulate if this was a building. I'm going to choose the final option here to extrude the surface, which, as it says, is used for buildings, and we'll click Apply. Now, in this case, my building is obviously not very well constructed because it's derived from the surface elevation, so my 10-meter values are not consistent in this case. But to show, again, how z-values can be assigned to an individual feature, just by way of illustration, this is an example. I'm going to close the 3D window just for a second here. Let me close the options box. I'm going to close my 3D window. Right now, the entire area feature has been assigned a single z-value. However, you can also assign a z-value to individual vertices. If I right-click and choose Edit after choosing the feature, I have the option to select this Vertices button. And this Vertices button will show me, for every vertex, the X, the Y, the length of the line segment between vertices, the total length, and the heading. But I can also use the button to add elevations. If I select Add Elevations, it's going to tell me they're not there. Would I like to add them? I'm going to say yes, and it's confirming that those elevation values have been added. I now have a Z value for every vertex. If I didn't have a Z value already assigned to the area feature, it would pull the Z value from the underlying terrain. If I didn't have any underlying terrain, the Z value would be 0. So depending on how your data is set up, you're going to have a pre-configured Z value. In this case, because my entire area was 10 meters, every vertex is now 10 meters. But I can now edit each individual elevation. I'm just going to exaggerate some of these elevation values so we can see the consequence of this procedure. Now, this is going to look awfully strange, but I'm taking two specific vertices, and I'm going to make those 50 meters instead of 10 meters. And we'll click OK. Now, initially in my 2D view, again, nothing has changed. I'm not seeing any difference. This is still in the 2D realm. But if I go into my 3D model once again, and let me bring the exaggeration down slightly here, you can see the obscure feature that I was able to create by individually assigning Z values to the two vertices you see here. Now, this brings up a world of possibilities as far as Global Mapper is concerned in terms of how you can model 3D features. This is, and I've used this analogy a lot in the past, a little bit like a cooking show, because I do have one that I prepared in the past. Here we have a series of area features to which I assigned individual Z values to specific vertices. And if I render this in 3D, you will see it looks like a little house. Let me increase the exaggeration slightly. And this was created entirely within Global Mapper by simply assigning Z values to particular vertices as I created these area features. So again, just as an illustration, Global Mapper does provide a lot of ability for working with Z values, not only within the context of terrain surfaces, but also, as you can see, applying these to elevations. If you have worked in SketchUp, which is an application developed by Google, now owned by Trimble, the SketchUp models can be rendered in Global Mapper. If you're interested in integrating SketchUp models, which basically are the same vector features extruded, you can download building models for some of the famous buildings in the world. Empire State Building is one I've used a lot. You will need to install the 32-bit version. It will not work in the 64. But basically, you would see the same end result where the actual building model, in that case generated in SketchUp, can be rendered in 3D within Global Mapper. I'm going to close my 3D window and look at my time. I have one more vector scenario to show you very quickly. Again, let me unload all my data. And we do not need to save. We're going to load up my final workspace here, and this one's called Subsurface. The Z value that I assigned to the house or to the simulated building was a positive value. It was essentially above the surface. But it's also possible to essentially model features or delineate features that are in a subsurface realm. Now, what I have here, just as an example, is I guess a series of radiating lines. These lines, if I click on my Info button, are not, they're actually got length and bearing. I think if I go into the vertice level, let me use my digitizer and we'll look at each individual vertice. Go to Edit. You'll notice they have a negative elevation value. There's only two vertices for this particular line segment, but they have a negative elevation value. In other words, relative to the terrain, these are going to be modeled underground, which again opens up a world of possibilities. We know a lot of folks who use Global Mapper are in the pipeline industry. So using this particular scenario, it's possible to model these features in a subsurface environment. So with the Z value assigned to these radiating linear features, I'm going to open up my 3D window once again. And again, I'm going to take a peek underneath, and you'll see now that we actually have, let me exaggerate this just a little bit so we can see a little more clearly. You can see now we have features that are not above the terrain, but actually below the terrain based on that negative Z value, and based on that negative value being relative to the terrain surface. In other words, minus 50 meters below the surface. So again, I use this just as an illustration to show you what the possibilities are when using Global Mapper to essentially generate features that can be modeled below the surface. Those can be areas, they can be lines, or they can be points. If you have point features below the surface as well. Anything with a z-value, whether positive or negative, can be modeled in this way. Now there's one final illustration I want to show you working with data with a z-value. And then we'll talk very briefly about exporting, some of the export options when working with the 3D data. Go ahead and close my 3D window. And actually, I have this one already loaded. Let me bring it up. Okay, this is another example of a LiDAR file. And the reason I had imported this previously and had this pre-configured is because it's a very large file. It would take maybe about a minute to import. The file actually is actually 3 separate files, and it's a total of, just over 40 million features in this particular layer. Now, unlike what we looked at before when we looked at our LiDAR example, which was essentially a surface model that was collected from an airborne collection system, what you're looking at here is LiDAR data that was actually generated at the surface. Now, from this perspective, it doesn't really look like much, but if I go into this 3D environment, what you'll see once it renders, and again, we're dealing with a large volume of points here, so it's going to take just a second to actually render. But what you'll see is a surface model. Actually, let me go down to vertical exaggeration of 1 just to make sure it's correct perspective. And every action here, because we're dealing with so many points, is going to take just a little bit longer. There we go. I'm just going to zoom in a little closer. This is LiDAR data that was generated in with a vehicle-based system. And you'll see the road system. Let me move along a bit. You can see it's some cars here. And you can see your perspective is not from a remote perspective, but from a terrestrial perspective. You'll also notice in this case that the individual points are not colored based on elevation, but each of these has an integrated RGB value. They have a color assigned to them, and that's what's being rendered by Global Mapper. So this just gives you an indication as to some of the applications for LiDAR and some of the ways in which Global Mapper can render this. Again, is a very detailed street scene. This particular file was generated by Optech, company out of Toronto in Canada, and again shows you what the future of LiDAR is. It's not just a remote airborne-based system, but can be used to generate features and to model a surface environment from a vehicle-based system. So that is a quick look at some of the ways in which Global Mapper can work with data in 3D. Generating terrain surfaces, performing analysis functions based on those terrain models, and also working with vector data in 3D. And Global Mapper obviously can work with the z-value regardless of what format it's in. As I mentioned previously, we will be giving you more information about the version 14.2 of Global Mapper in next month's webinar. We were looking at both the Global Mapper and Global Energy Mapper 14.2 versions today, but next month we will go into more detail on the functions that have been added for that. For today, we looked at the sources of 3D data, generating our elevation surfaces, the configuration of our 3D view, the things like the shader pattern and the hill shader. We touched on some of the terrain analysis functions. There are tools that I didn't have time to work on today, things like profiling and viewshed modeling, which are available within Global Mapper. Manipulating elevations to create a flattened surface, generating those flattened surface models to create a pad site, for instance. Working with 3D vector data, the limitless possibilities in assigning a z-value to a feature or to a vertex that defines a feature. We didn't talk about exporting, unfortunately. I guess my time is up, but needless to say, when it comes to exporting those elevation files, Global Mapper includes a long list of available formats for exporting. There's a export component within the file menu for exporting those elevation data sets, including generating LAS and generating LAS. Those LiDAR data sets can be generated. So that is a very brief look at some of the 3D tools within Global Mapper. Thank you so much for your attention, and hopefully those of you who had questions, some of my colleagues were sitting in the sidelines answering your questions. If we didn't have a chance to answer your questions today, there is a email address right where my cursor is located, geohelp@bluemarblegeo.com. Those of you who maybe have some older information will make note that this is actually a new email address. geohelp@bluemarblegeo.com is the way you access help for Global Mapper. Also, if you're interested in transitioning from the standard version of Global Mapper to Global Energy Mapper, or upgrading from an older version, GM Orders is where you'll want to send your email. And training, if your company is interested in getting some more specific information about the use of the application in your context, you can send an email to training@bluemarblegeo.com. Once again, folks, thank you very much for and your interest in Global Mapper and Global Energy Mapper, and we look forward to working with you again next month. Thank you.